Today I'll be talking about computer network and its basics. Yeah! Well, computer network is basically a network that is probably the most familiar with us this day. Everyone has a computer in their house, right? Well, computer network is basically a network or link that is connected between computers, like this, in order to transfer information from one computer to another very quickly. So example, information from this computer can go to this computer very quickly through this network. LAN or local area network is one of the three types of networks that are most commonly used currently. LAN is the smallest type of network out of all three types. It is a computer network that is used only in a house or a building. It does not include multiple buildings, so it can be only inside your house, not the other parts of the city. MAN or Metropolitan Area Network is the one that covers commonly an entire city. It links between multiple buildings or houses, and it only has the range of under 30 miles. It cannot go over 30 miles. It covers the entire city. WAN or Wide Area Network is the biggest type of network we have currently. It usually has the range of over 30 miles. It connects multiple cities and areas, even a country itself. And internet is the biggest WAN we have ever yet. So these are the three basic types of network we have currently. Node is any kind of device linked or contained in a computer network. It can be a computer or printer, for example, which are the most common. So they're all linked to each other, and a computer is a node itself. Printer can be a node itself too. All nodes are connected to each other through devices called communications media. Communications media is a tool used to connect each node basically. The two most commonly used communications media are cables and fiber optic cables. Cable is the more commonly used one, and people use them in their work or houses for basic functions. And then it is more simple and common compared to um, the fiber optic. It is usually single stranded and connects to the different nodes. And the fiber optic cable is the more advanced one and the rarer one. It is used to connect fiber optic network, which is more complicated, and then it's way more advanced and functional compared to the cable. That's basically about the communication media and the link with nodes.
Alright, so there are a lot of words that you need to know in order to talk about networking. So, one of the words that you really need to know is called workstations. And workstations are basically personal home computers like the one you see right here. Um, Another couple words that you need to know are clients and hosts. And so, clients are any part of the network that receives the data, and then hosts are any part of the network that gives out the data, or it's a place where the client gets the data, or places like news or Facebook and stuff like that. And so now, if you see here, let's say that computer is the client, and this computer is the host. And so the client over here will go over to the host like this in order to receive information. And so the host then recognizes it and then gives the client information back. That is how clients and hosts work. Now, another concept that you really need to know is called servers. And now servers are it offers different users to access the same information. So for example, a website can be an example of something that would be a server. And so if you see here, that is an example of a server. And these are computers that access the same information. Now let's say all these computers want to go to the same website, like Facebook. So this computer right here would access into this one, and then the second computer would also do the same, and same for the third computer as well. So that's how servers work. Now third, there is the NIC card, or the network interface card. And what it does is it's basically connects you to internet. So that is an example of a NIC card. And there are a few commonly used NIC cards. First of all, there's the Ethernet card, which you see right there. It basically connects you to a cable modem. And then there's the telephone NIC card, which connects you to a telephone line, which you just saw right there. And then lastly, there's the wireless card. It's a special card that you don't need any lines or cables. It directly connects you to the internet. So all these NIC cards that you just saw allow you to connect to a network.
So today I'm going to be explaining topologies, and what a topology basically is a network's shape and structure. So it's how the data gets moved from place to place, like a computer to computer or node to node. And the 5 basic topologies are bus, ring, star, tree, and mesh. So first, the bus topology, there's basically a terminator on each side, which is basically when the data goes here, it's destroyed. So there isn't any excess data here that's causing noise or anything. So the data is connected. Well, it's connected like that, and then there's a computer. It's connected to this. There's a server connected. There's also another computer. And how the data moves from this computer to this computer is the data moves from this computer to this, then it moves along, it goes to the server, and then it goes along again to this computer, and then it finally goes to the terminator where the data is destroyed. This way the data won't leave any excess data here, which will cause overload on the server. The next topology is a ring topology, and not like the bus topology where the data is eventually destroyed. Here the data continually moves around the ring, and there's a couple of computers connected. And if this computer wants to send data to, let's say, this computer, then it sends data through this, and then it goes around the ring, and then it goes here to this computer where the data is saved here, and then it moves along to the other computer where the data is finally reached at its destination. So unlike the bus topology, there's no data destroyed, but rather it keeps moving around the ring.
Now we'll be learning about the data link. But looking at this, can you find the data link? Yeah, you're right. It's located right here, and it's above the physical layer. But this is what we'll be learning about. The binary code. For those of you who still might not know, binary code is made up of 2 numbers, specifically 1s and 0s. So it can, for example, look like this, something like this. And what the data link layer does is it puts it together and then this, and it will organize them into something called frames. And now we'll be learning about what exactly frames are. Frames. So frames is a very important part of this whole process. And what it does is it does two main things. It gets the address. And what kind of address does it get? It gets addresses from, and so where the address is coming from. And by address, I don't mean where your friend lives or anything. It's the address of the computer, and it's called IP address specifically. So basically it gets the addresses from where the information or data is coming from, and to, so where it's going. And another thing that it does is that it checks errors on data. So it's a very important role, as you know. So what happens after the physical layer? So we learned about the physical layer already, and now we want to know what happens after this. So this is an iMac, one iMac, and this is another iMac. So basically, for a very short review, there is a connection between this, and let's say this is the connection, and what's this called? And this is the physical layer. And what it does is that it takes the binary code, which we just learned about. So let's say this is the binary code. So it groups them together, puts them together. Basically, let's say it puts this together, and then it basically kind of finalizes it and puts a I guess you can call a stamp on it, and which kind of directs it to other computer. It's not going yet. It just puts the address on it and makes it all ready for what's gonna come, which is the send off. And what else it does is that it checks for signals. It checks if there's the same signals. We don't want the same signals, right? And so it basically checks if they send in the same signal, and then, or if not only that, or if they're not sending enough signal, so then from one computer to another. And again, for review, this is where the data link is located.
Now we'll talk about the transport layer. The transport layer is after the network layer, and they're both similar, but the transport layer basically helps the network layer, and it has two jobs. First, it finds the fastest route. So let's say there's one computer here and one computer here, and this computer wants to send data to this computer. So there may be many routes, a long one, and transport layer basically goes through all the routes and gives them gives each of the routes a unique identification number value, and it's also called a port number, and it gives the number to each one and then finds the fastest route, and make sure the data is sent through the fastest route. Now the next job transport layer also checks for errors in the data, and it makes sure the data is sent or received in the right order. And network layer also checks for errors, but the difference is transport layer checks for different type of errors. So it checks for errors that network layer doesn't check.